Welcome back, and welcome back to my channel. I don't know how you pronounce this thing. Klipsch SW-450 home theater system. This may be a down-firing subwoofer. Yeah, it is. Subwoofer's at the bottom. Customer said it just quit working. Doesn't know if it's the speaker or the amplifier section, because obviously this is a powered subwoofer, which means we've got low level audio coming in, being amplified to a degree. I don't see any. Yeah, it could be phased 180 out, and we can verify if that works. And then setting your low pass filter or all the way to bypass, let all the audio signal through, which I don't know why you would do that for a subwoofer. You know, typically you're looking at, I presume, around 80 hertz, maybe not low 40, unless you had multiple subs, but probably around 80 hertz, 80, 90. Usually when I'm messing with a subwoofer, that's where I get the most optimum bass at. But fortunately, we could test it out, determine if it's an amp issue or if it's a speaker issue. He did provide much needed RCA cable and the power plug. All right, let's check this fuse out here. Yeah, we're good to go. That's just me not getting the leads on appropriately. Yeah, fuse is good to go. Okay, with the fuse back in and everything powered back up. Again, there's no light bulb, so you know, maybe it's just low current, maybe it's just not drawing any current at all. What I'm going to do is I'm just going to increase our amplitude here a little bit, just in case. I'm not going to go over a volt. And let's change the frequency. We can do 80 hertz. And still nothing. So yeah, shut that off. We will we'll begin to troubleshoot some things. I'm gonna get the speaker out and we'll ohm it out first, and then we'll take a look at the amp. And when I do, I'm getting well, my hand's not too steady, but like 5 ohms. Forgive it bouncing around. That's not my multimeter, that's me and my fingers balancing this thing like this. But so this is either what, a 4 or 6 ohm speaker. So the coil is good. I can test it out directly with some low level audio, which means that the issue is probably most likely on the amp side. So we're going to get this back piece out and start troubleshooting from there. Okay, with it out, I'm going to put a 4 volt peak to peak signal through. Currently got it at 320 hertz, and you can hear that. Yeah, we're getting into those bassy tones now. It's more baritone. Hopefully that's picking up. So I don't think the issue is with the speaker, as demonstrated just by this simple test. Most likely with the amplifier. That actually might be good news for our customer, because this could potentially be more expensive to replace than any component that's on the amp portion. So yeah, now it's I just need to take this out and might be able to fit it up on the bench, and we could test from there. We're on to practice some precautions because a lot of those tests are going to be with mains AC applied, and obviously the circuit's going to be open on my bench, so definitely an electrical hazard. But you know, when you do these things for a living, you just take precautions and you take time, so you're not endangering yourself or you know, endangering the equipment as well. I did find where the LED indicator is at for this thing. Looking through that side over there. But yeah, the LED is up front right here, but as shown, no light. Okay, so we've got it apart, as mentioned, up on the bench. And again, because the LED isn't coming on, that comes from this card over here on the right. I disconnected it from some pins down in here. My assumption is that we are not getting anything from our low voltage side of this power supply board. And just taking a bit of a look, I think I see where a potential problem might be at. Question is can you see what I see? Hopefully you can. Definitely some burn residue adjacent to this capacitor right here. Put it back and that's not a shadow, that's literally burn residue underneath this capacitor. Like it's fried. Markings on this 102 or something like that. I'm willing to bet that that feeds essentially this guy right here, which is going to be a basically a rectifier, probably a high-speed rectifier of some sorts. So we'll do a little bit of internet sleuthing for it. Just peering underneath the board, it does look like the leg from this cap down in here does touch the far right leg. What I previously thought was a MOSFET, but it's not. It's a rectifier. And so kind of wondering if there's a short across that rectifier. It's caused that capacitor to kind of go bad. So center pin should be cathode, so you know, if I go from here to here, that should measure like a diode, and then from here to pin 3, pin 2 to pin 3, yeah, it still reads like a diode. That's good. What if I go from anode to anode? Okay, there you go. There's the issue. That rectifier is bad. Now, this capacitor right here is probably also bad. They put so much stupid celastic or goop or adhesive onto here, like, you know, just here it's multiple different types too. There's this brown type you find everywhere. There's this white booger snot everywhere. But here there's some brown mixed with the white, and right up against this resistor here, it's kind of gone flaky and burned away. So possible that this resistor has been underneath extreme heat because of current. excessive current. But I want to check this resistor here first, though. Was that red, black, black? That should be a 20 ohm resistor. There we go. Yeah, it's 20 ohms. So that resistor looks like a massive wire round resistor. It's looking pretty good. And then this bottom one down here, red, black, red, and then tolerance is covered by, I assume it's going to be 5% like the last one. This should be 20K. Yeah, 20K it is. So, most likely these resistors are going to be, I hope. Now, get a good measurement off of that cap down there, and what is on it? It looks like a 102. I need to turn it around and verify. Yeah, it's either 102 or 103. So we're only talking about 1,000 picofarad or 1 nanofarad, or maybe 10,000 or 10 nanofarad at a 50 volt rating, which I've got many of them, so I'm not too worried about that. That'll be easy. I don't, however, have this rectifier, so, and there's no sense in me troubleshooting anything else beyond this, because with no power, can't look at anything over here. So I have to get a few of these ordered up, capacitor replaced, because those are the obvious things that are standing out. We can attempt to power up the board from there and see what we get in return, and see if more troubleshooting and diagnostics is needed. That all being said, you should all know me well enough by now, and when it comes to finding a subcomponent, I will do it, especially if component I'm on the board looking like it's going to come internationally or by AliExpress or, you know, an eBay buy. I don't like doing those kinds of things. So here's our data sheet that we have for YG906C2 20 amp low loss super high speed rectifier. And what else do we know about this guy? Oh, we get down here and start looking at it. Zoom out a bit. There goes the diagram. Anode, anode, cathodes at the center. There you go. And we got some data we can obtain. Let's see, peak, repetitive peak reverse voltage. I'm looking at 200 volts. Average output current, 20 amp. Got a little asterisk there. Forward voltage drop, at 0.98 volts max at IF of 10 amps. Reverse current, 200 microamps. Let's see, recovery time 35. So we should be able to find a sub for this. Let's do a bit of digging. And digging I've done, and here's what I've been able to essentially determine. We've got this product from Mauser. Let's see. RFN20 T10 DNZC9, and I've got the data sheet for it pulled up over here, in which we could do a bit of a comparison. For instance, let's see. Pin for pin, it's exactly the same. Dimensions are fairly similar. Yeah, 2.5, 2.5 spacing. Then, okay. Yeah, the spacing is good enough. That should work. I'm not too concerned about that. Yeah, screw, eyelet here and here. Yeah, about the same, so not the same. So that should be good. Yeah, we're still looking at reverse voltage, 200 volts. That's good. Duty cycle seems to match between both. So I'm not too concerned about the duty cycle between either one. Rating 20 amps. 20 amps, SRIO, average output current. That's good. Let's see. Our storage temperature, yeah, roughly the same. Not seeing, let's see, operating. It's only giving us the upper end 150, so yeah, I think that's going okay. The volt max 0.98 V max. Let's see, 10 amp IF, yeah, so IR is slightly different. Our reverse recovery time is quicker. Well, no, that's 200 V, so yeah, so that makes sense. I don't think this is correct. Same microamps, but it's not really giving us the amp rating. So that must be our VR 200. But either way, other calculations look pretty similar, but the junction to case thermal resistance slightly lower on this, but quicker recovery time. So all in all, I think this one's going to work okay. I have no qualms about getting this product from Mouser placed on order and put in there, especially as almost 2,000 are ready to ship immediately, and our quantity or price, minimum buy of one, is about $2.50. So not bad. This is what I'm going to order if he gives me the go ahead to repair this product. Okay, we have parts, and so it is time to start tearing down this board and replace and I'll remove these two components. I'll probably test them out of circuit as well, and then getting them replaced. Hopefully nothing else is wrong with this PCB. I don't believe there would be any other issue, because our main fuse hasn't blown, which tells me there's probably not an issue on the high voltage side. Our LED is out, that indicates low voltage side, and most likely, with this right here measuring bad, our rectifier, and that capacitor, at least in circuit, appearing to be open, this tells me that's the reason why we haven't drawn excessive current with it currently plugged in and trying to power it up. Simply put, it's not developing that lower voltage. So hopefully with those two items replaced, nothing else is bad, but we'll discover that. Like I said, now it's going to be tearing this down and replacing these components.
testing our components out of circuit, and the old rectifier out of circuit, doing perfectly fine. The voltage drop is slightly different compared to the component we'll replace it with. Additionally, and I misspoke in the past, so this is a 1 nanofarad capacitor, but it's not 50 volts, 1 K. I'm still measuring 1 nanofarad, despite burn mark underneath it. Again, we're going to replace both of them. But we're also going to have to, because I am now unsure if these are the issue for no output, we're going to replace them, but now I'm going to have to troubleshoot the board some more because I'm feeling like there's something else amiss here. So why was that shorted over here? Well, we're coming off of this transformer here, and that's kind of a bad indicator. We actually need to put it onto a resistive measurement, and we can see that just that that terminal is 0.4 ohms. I mean, it's a very low resistant output, but it's the same across all these terminals, to be honest. So I imagine that the windings are very few windings on this end. There's no direct short across. Transformer is providing isolation. However, there are some very poor soldering terminations here on the board that I can touch up as well. So I think the best thing for me to do is still get these two components replaced, and then power up this board and do something that I typically try to abstain from, and that's doing measurements on a power supply PCB while it's energized. But there really is no way around this. But yes, that's the way we're going to have to go. So I'm going to get those components soldered back in, and we'll do some more troubleshooting. Okay, I've got this loosely fit back together, and I'm not plugging these cables into, kind of got them pulled off to the left a bit, because I know this is a, looking at the board, this connector here, you have a positive 9 VDC rail and a negative 9 VDC rail and a ground. And then these two pins here, I believe, generate 48 volts DC or something along those lines, because when I check the connector on the other side of the board over here, I see a positive 48 volt something stating positive 48 volts printed on the silk screen or whatever on this PCB. So with those components replaced, again, they were testing somewhat fine. I mean, they appear to be fine outside of the PCB. 1 nanofarad, and the diodes for the rectifier are testing like diodes. And we know the short is because of this transformer, which could actually be okay depending on how many windings are on that output. So if it's not a lot of windings, I wouldn't suspect to have a whole lot of resistance. And we're going to see if we have this 48 and 9 volt DC. Now, I suspected that the issue is on the low voltage side, and I suspect it's dealing with that 9 volt. Given the burn marks that we saw on the PCB, potential for those two components to be bad. And I didn't check the voltage beforehand, primarily because I probably should have done it, but I don't want just random plugging and then turn it on to create more issues than what's already there. So we'll at least verify now, and I'll set this to on. And we're not going to get an LED indication over here because obviously I don't have it plugged in. But I'm going to go turn on power to this, and hopefully there's smoke. Okay, we should have AC applied now, and we should be able to check if our voltages are indeed back. Yeah, we have the 48. I mean, it's a bit high. It's 49. Tell you what, because my hands aren't that steady. Yeah, let me try to do this. I don't have the world's steadiest. Okay, so we have our -9. See if we've got our +9. +9. And they appear to be stable. So let me turn this off. Plug in this. Okay, let's not make that mistake again. Of course, you need to let the high voltage side discharge or connecting anything over on the other side, unless you provide a path for current to flow. On we go. All right, with everything plugged in, I'm now going to check it again. See if we're still good. All right. So we're 49. Still got our 9 there. And we see that that +9 has dropped with that connector put in. Hopefully that's picking up. We'll change the frequency on it. Currently at 80 hertz. We'll go up and down. But yeah, there you go. Okay, a lot of that testing out of the way. What I'm also going to do, since that voltage is varying a lot on our positive rail, is remove this series of capacitors and that one transistor in the middle, and the bottom series of capacitors and the one transistor down in the middle, and test them out of circuit too. Okay, with these components removed, now I've checked capacitance on them. And here goes the negative rail, here goes positive rail. Positive rail is the one that's varying a lot, causing the device to take forever to turn on, even place components that we put in. So 215, that's a 220 16 volt cap, 220 microfarad 16 volt cap. It's reading relatively close. I imagine they're 20%. So now this one is way off. Supposed to be 220, we're at 160. Okay, this should be 100, and we're a little off. $100, yeah, again a little off. 20%. Those two should be fine. This right here is definitely way out there. Now, these two components, this is a 79 L09 in a TO92 package or form or shape. This is a negative voltage regulator, so it regulates at -9 volts. This is our positive voltage regulator, 78 L09 in a TO92 package type. So I can use the SIGGEN test these guys, so give me a second, I'll get set up for it. Hey, never mind the quasi jankiness of how I'm going to test this, but got everything hooked up. I'll use the SIGGEN. You go across the output pin, so input pin, pin 1, flat side is on this side, round side is on this side, so flat, round, right? Pin 1, 2, 3, 2 is common, 1 input, 3 output. So, and then I just tied both grounds from the signal generator set to output DC, and my ground lead for my multimeter here. And then we're going to take the positive lead to pin 3 and start increasing. And let's see if it regulates to 9. Should be around 12 volts that we get. Yeah, regulating it. Regulating at 9.5. So, or what was that? Around 9.5. Oh, sorry. Around 11 is starting to regulate at 9. 11.5 and 12, it stays steady at 9.06. Okay. That guy seems to be working just fine. Okay, and now we have in the 79L09. Front side facing us, round side facing away from us, front, round. This one, pin 1, pin 2, pin 3, front side facing us. Pin 1 is actually going to be common. Pin 2 will be the input. Pin 3 will be the output. So again, we're going to check on pin 3. Really the only change is what's common and what's the input. And as suspected, you know, it's gonna go, I can't go any greater than -99 on my offset. This is what it is. Maybe if I lower the hertz, maybe I can go higher with that way. 100 hertz. Let's see. As much as I can go. But anyways, yeah. It is definitely regulating as well. So we're gonna call that good. The only one that's bad is this 220 microfarad, but we're gonna replace. I'm gonna replace them all anyways. I mean, they're electrolytics. So, and then we'll check them out. Put this all back together and see how it performs. Okay, got all those capacitors replaced. The question now is our +9 going to be swaying like it was previously? Oh, power on is going good. Nothing is be a bit blurry. Nothing has gone boom, so let's check our voltage here. Yeah, and we are steady as can be. Here, I'll move this up a bit out of that light. Steady 9. Steady 9. All right, cool. Well, let me get this once again back into the amplifier, and we'll see how long it takes for it to power up. Because if you remember, I mentioned it took a while, so we'll see if it's instant on or if it takes a while again. Okie dokie, $1 million question. Will we get an instant on, or is it going to take forever to warm up? Hey, that is instant on. All right, let me turn on our audio. And let's see if yeah, we do have audio. Ooh, I didn't realize that was these are shorted. Hold on a second. Yeah, they had those definitely touching each other, but there you go. Off and on. All right. So let's recap for a minute. We had some burr marks around the rectifier and a 1 nanofarad 1K volt capacitor. We replaced both of those. We hooked everything back up. The positive 9 was VDC regulated voltage was wavering. Well, actually it was solid, and so was a negative 9 until we plugged back in the audio board, and then the positive 9 started wavering. Okay, so from the positive 9, even though it's still wavering, we went ahead and tested out the amplifier anyways. It took some time, but eventually the audio came through, okay, because that voltage was not good enough. We were able to test out the audio through the entire board. It didn't all look good. And then we put everything back in just to see if it could drive the speaker, and it could, but it took forever to warm up because we needed to turn on, because we needed to resolve that issue with our positive 9 volt rail. So we took everything back out and troubleshot it down some more to a 220 microfarad capacitor that also needed to be replaced, although we went ahead and replaced all the caps because why not. I am very happy with this and glad I'm able to now return this back to the customer, and he should get some enjoyment out of his subwoofer again. That being said, thank you for watching. If you're new to this channel, please consider subscribing. If you like this video, please give it a thumbs up. Man, I got so much cleaning to do. I operate Having Fun Repairs as a business here in the state of Oklahoma. Information about the repair side of things is in the description. Take you to my Google site, shoot me an email, we can work something out. But all that being said, thank you so much for watching. Take care and goodbye.
Bark.